Hi, good night. My name is Miguel Angel Flores, and this is my project fast food storage system using Stack and Queue in Java. Okay, what's the problem overview? The problem overview it is in fast food business we have a fast information flow. What does that mean? We have a lot of orders that need to be stored with a lot of amount of details. For example, the name, for example, the weight, for example, the best day to consume, the best before, and the timestamp. How can we deal with that? Okay, we can deal with that with stack and queue storage methods. What does that mean? We are using an array and we can use two systems to store the information. That is stack, that means the last inning first out, or first inning first out that is used by queue. What is the difference between one of them? Okay, as first, let's say we have the last innings, that means the last thing to enter in the system, it will be the first out of the system. Otherwise, in the queue system, we have the first inning is the first out. And we have the operations, that means push and pop to stack, and we have the enqueue and the queue for the queue. Now, how can we do that? We can do that with a NetBeans program with a main program and another four classes. The first class, it is the food item that this stores the name, the weight, and the date before. Then we have the stack class and the queue class. This is the method of the program using last inning first out or fifth inning first out. Then we have restores like answer controller enforcing the capacity limits to the operations. Then we have the storage system that it would be the interface between the user and the program. Obviously, it would be completely friendly using main menus and things like that. Then we have see here a UML diagram when we see all the variables, the type of the variables, and then the action that we have. When when we need to explain the system that is a restaurant storage system that uses obviously the storage, and this depends directly from the stack queue classes, and then for the food and then for the food item. Now we can talk about the algorithms and operations. For each operation, we need to rate of complexity. For example, add, remove, pick, and add, remove, and pick. Use this one, and display and search using another one. What is the advantages and limitations? The advantages that is a fast constant time. That means does not require a lot of time. Can be adequate for the fast food for the fast food flow. Accurate with the real world dealing. Uh, it's so simple to use. It's so easy. How can we have some, well, we have some limitations. For example, it is a fixed capacity from 8 items, just 8. We cannot add more. Uh, we don't have random access. For example, we cannot jump between stack and queue, and for example, like that. Then for the display, we have to make the linear search. Now, the testing and validation. Here we have the main program. Here it is, with the menus, with the interactive menus for the main program. The food item, we can see it here. The storage in the name, the weight, the best before date. We have the two methods, that is the queue, the stack, and then we have the storage. And let's try it. So sorry. That's it. We can use the first one. No. First, second one. The queue system. Now, how can we add food? Let's see. One, add food. What is the food name? Burger. Here we have the weight in grams exactly. What happens if I use this? Invalid weight. Please enter a number. That's it. We have a conditional there. So 500 grams. It could be. What was my mistake? Oh, yeah. So sorry, the information was not added. Sorry. What is the name? Burger, weight in grams. That days before. Now using this format, we can say for now 20 an express burger. We need for tomorrow. We will continue to add some items until we have the storage completely full. Okay, finally we have finished to enter all the information, egg the spaces, as you see here. Let's try to display it again. Here, choose a valid option. So sorry, my mistake. That's it, that's better. Yeah, eight items here, each with the weight, the date before, and all the date. So now let's try to add another item that is full completely. We cannot add more. Okay, so let's try to remove them. Remove. What is this one? That means the burger, food item burger, it will be removed. Why burger here where we have the first inning, first out? That's the reason why. And in the display again, we can see now the 7 inches and the 7 items and the sandwich will be moved to the first position. And this is the storage system. So much thank you.